Welcome back to Pachehra Talks. My name is Arun, and I'm working as a solutions architect with Rackspace Technology, which is one of the best organizations to work with. And these are my views on Azure Databricks as we are completing AZ-305. So you're not getting deep dive into it, but yes, things that we should know because we're gonna design those things. So we should know the pricing, we should know these queues and how it actually works. So welcome to the Azure Databricks. So the very first question comes into the mind whenever we start any new topic, like what is Azure Databricks for in today's sense. So Azure Databricks is a data analytics platform optimized for the Microsoft Azure Cloud Services platform. So what does that mean? That means it's a PaaS service. So we need to actually understand Databricks in little deep. So let's try to understand it, which seems very similar to Azure Synapse. Yes, that's true. However, originally, Synapse Analytics and Databricks were two different products with different feature sets, but now it is very similar to Synapse. If we have to define Azure Databricks, well, again, it's a big data analytics platform which is built on a top of Apache Spark and Databricks itself. Databricks itself is actually a product that can run on any hypervisor. So it's not just MS product. However, if we talk about Azure Databricks, MS manages everything behind the scenes. Remember, I said PaaS service. So just like any other PaaS service, MS manages a lot of stuff, which means you can have Spark cluster created automatically for your workloads and deleted and can run your different jobs. But here we are talking about big data analytics. So let's check different environment that it supports. And prior to that, you can see the big architecture of Azure Databricks right here that we'll be covering in this video or maybe upcoming video. But on a high level, you can see data uh, getting in, going to Databricks, getting out, used in Power BI through Synapse or machine learning, things like that. So it's a high level architecture to just give you an idea. But for now, let's check the three environments. Databricks offers three environments for developing data intensive applications. As you can see, Databricks SQL, Databricks Data Science and Engineering, and Databricks Machine Learning. Databricks SQL provides an easy to use platform for analytics who want to run SQL queries on their data lake, create multiple visualization types to explore query results from different perspectives, and build and share dashboards. If we talk about data science and engineering, provides an Databricks provides an interactive workspace that enables collaboration between data engineers, scientists, and machine learning engineers. For a big data pipeline, the data, whether it's raw or structured, is ingested into Azure through Azure Data Factory in batches or streamed near real time using Apache Kafka, Event Hub, or IoT Hub. This data lands in data lake for long-term persistent storage in Azure Blob Storage or Azure Data Lake Storage. As a part of your analytics workflow, use Azure Databricks to read data from multiple data sources and turn into breakthrough insights using Spark. If you remember, that's what it was showing in the previous slide. You see, Data Factory, Event Hubs, data from various sources coming here and moving in both the direction, and Databricks are doing all its magic. So the third one is Databricks machine learning. It is again an integrated end-to-end machine learning environment incorporating managed services for experiment tracking, model training, feature development, and management. So these are some terms from machine learning. And if you have to see how it actually looks in the Azure portal, so let me show you how it looks in the Azure portal. That's how it looks. Okay. These are the three environment, as you can see right here: data science, engineering, machine learning, and SQL. These were I was talking about. All right, so let me quickly go ahead and check the general flow that we have already talked about a little bit, but let's try to understand it in a little deeper. So what does this really look like? Well, again, it's quite similar to Synapse Analytics, as we have already established that. So we are going to have some sort of data that we might be streaming from business apps, custom apps, maybe sensors and devices, as we have already showed the previous big architecture. And ultimately, this is the general flow, and we have seen the big architecture in the second slide. And ultimately, we are trying to get predictive analytics about what might happen in the future. Yes, it's not really for simple basic reporting. This is for far more advanced job, right? So you have this data that you need to ingest. This is representing all different kind of data coming from different things, so which you might be streaming through Apache Kafka, Event Hub, or IoT Hub, as we have already shown in the big architecture. You then need to send that somewhere, from where you can have the access and work on it, like Azure data lake storage, and then over to Databricks, where you might actually interact with it. So uh, Databricks can interact with your data in a range of different ways, depending on what workspace you're working in. Remember, we talked about three different environment at the beginning. So in this whole process, Databricks is not the only resource we're using. We know we need to move data, and we have already covered what we use for data movement. Any guesses? Yes, Azure Data Factory, and Databricks works with it pretty well. So this is what we are talking about with the Databricks. It is very versatile system. It helps in big data analytics, can ingest data for a range of sources and a range of ways, can model and serve it across the other services, and much more. Now, depending on what you're trying to do, there are few different ways that you might work with Databricks, such as three environments that we talked about, uh, which we already covered. So what are those? Let's refresh it quickly. We can have SQL environment, which is where you just want to run the simple SQL queries on a data lake for visualization or reporting. You can have data science and engineering, when you want your data scientists and data engineers to collaborate together in a single workspace where they can work on big data pipelines and analytics. And finally, you can also get machine learning, where you want your end-to-end machine learning services, if you want to experiment, train, model your data, and much more. So these are the three Databricks environment available to us when we are using Azure Databricks. All of them are generally going to connect to data. They're going to have some sort of compute that's massive, that's running your jobs, and an ability to actually go uh, and interrogate data and present it. But depending on what you're actually trying to achieve, you have got these three different environments available to you. Now, when we create our Azure Database service, we need to understand there are two pricing model. There is standard, where we just get basic Databricks functionality, uh, even excluding the SQL environment that we just talked about. You can have premium offering. That's the second one, that includes a range of different features like RBAC, role-based access control, RBAC, Azure AD pass-through, IP access list, security auditing, monitoring, and other security and management functionality, as well as SQL workspace. Yes, if you're thinking SQL, then you have to choose the premium. So that's what we are talking about with Databricks. It's another big data analytics service that can help us to ingest data, interrogate it, work on it, model it, train it with ML, and much more. So, when to use this? That's a big question because we are in AZ-305. So, yeah, that's the question. When to use it? Well, we know uh, Databricks is entirely based on Apache Spark, and as such, is a is a is a great tool for those already familiar with open source cluster computing framework. As a unified analytics engine, it is designed specifically for big data processing, and data scientists can take advantage of built-in core API languages because it supports five: SQL, Java, Python, R, and Scala. So with this, when to use, we can create, clone, and edit clusters of complex unstructured data, turn them into specific jobs, and deliver them to data scientists and data analytics for review. Yes, data science, preparation of data. We can think for Databricks in such scenarios. Recommendation engines, churn analysis, and intrusion detection are common scenarios that many organizations solve across multiple industries using Databricks. Create a collaborative environment and shared workspaces for data engineers, analysts, and scientists to work together across the data science lifecycle with shared workspace, saving teams precious times and resources. So, improve productivity. Leverage data lake and engine to get the best performance reliability for your big data workloads and to create no fast multi-step data pipelines, right? And finally, machine learning programs. So leverage integrated end-to-end machine learning environment, incorporating managed services for experiment tracking, model training, feature development and management, and feature and model serving. Well, that's not it. That's not it for sure. Data in itself is a huge thing, and Databricks, it's a big, huge service. Uh, this is with regards to this particular playlist that we are trying to work upon. So this is to just give you some insight how it actually work, why we use it, different SKUs, and when to use which one. So I hope it helped. Thank you for watching and take care. Bye bye.